This morning on the subway or on the bus, I started thinking about Ted Nelson's project Xanadu. I don't know much about the project, but according to Wikipedia, Wikipedia cites that Project Xanadu, which has probably been in development since the 60s, and some version of it was released in the 90s and eventually to 2014. It's a long time in the making. The people who've been working on Project Xanadu, I don't know if it's the quote from Ted Nelson himself or the other members of his team, but they cite Xanadu as an improvement over the World Wide Web. So I'm just pretty much paraphrasing what the first couple of paragraphs of Wikipedia say. So the way the World Wide Web is structured, you don't have version control of the links. You don't have an inventory, so to speak, of links that are broken. And these are all valid comments, and these problems are now solvable with the emergence of the new technologies. But my thought was specific to books or documents that could talk to each other. And I started thinking about what would it take to be able to manifest or usher that kind of a reality. So I didn't get a chance to obviously think about this too much, just thinking about it for 5 or 10 minutes. I haven't done a lot of research, if actually no research at all. I just got to this space and just did a Google search for documents that talk to themselves or books that talk to themselves. What search I did? It looks like I closed that tab. So I don't know if I've made another video about this, but this is an interesting topic because you have something stored in a document, and right now we have things like Watson, which is the machine's ability to be able to parse through the information and make coherent sense out of what's written, and then give it a probability that the machine is this percentage confident about what is being shared. So that's still as remarkable of an achievement that it is in terms of computer science and the history of computer science. That's still related or focused on that document itself, or whatever is what you see is what you get kind of thing, or whatever's in front of the machine, or what is being programmed to do in, I guess, that respect. Or you could also parse through a whole a whole bunch of data or a whole set of documents and come up with a summary of sorts, or kind of say based on the query, this is what meets the information, or just come up with one answer. But what I'm thinking though is documents that talk to each other, or books that talk to each other. So this is a hard problem because how do you go about creating something like that? In a future sense, perhaps you could do this with something like OpenCog or the OpenCog project. You could also do this with mostly, you need some kind of a mental model in order to be able to make sense out of what's written in front of you, and the ability to be able to document that in some repository. But if you kind of trim it down to the bare bones, then any document is comprised of a representation of symbols that we give meaning to in the form of letters. And those letters make up words, and the words make up sentences, and the sentences make up paragraphs. The paragraphs make pages, and pages make books or documents. And it kind of reminds me of my comments on Quora about the ability to be able to wrap your mind around a subject, which is an interesting topic. But if you want books to talk to each other, how would that happen? Like, what does that mean, first of all? Talk. Well, this is not the I don't, well, not yet, at least not the interactive uh, intelligent discourse between two entities or knowledge set. um, I'm more so thinking in terms of X entity is pertinent to Y entity, and there's something similar maybe that's on the periphery. It's not exactly similar. It's like a Venn diagram. We kind of converge on these areas. Let's talk. How do you do that though? Well, the logical thing to begin with would be in terms of cognitive computing. Uh, from the very few videos that I've watched on Udacity, first there's this classification. So, excuse me. You classify what the document entails. So you give it some kind of a primary classifier, then a secondary classifier, then a tertiary classifier. And it's up to you how many layers of classification you want to get into. But this is from Ashok Ghol's class on Udacity. I think the course may still be there for cognitive computing. But once you've given the document classification, that would be kind of like its marker in terms of where the document resides in a larger ecosystem. It's kind of like how you categorize species. So you have a genus, and you kind of document flora and fauna in those specific categories, and you kind of go from there. And you kind of branch them together. There's no allegory to. I'm not going to get sidetracked and talk about biology because there's no tree of life, according to Craig Winter. But so you start with the classification, and that makes the job of at least documenting where that particular entity, for lack of a better word, is supposed to reside in, again, a larger ecosystem. I'm repeating information at this point. So once you have the classification in place, then you start, you can have however the document structure, you can have an index and whatnot. That's not exactly that much related, but then you have information within the documents in terms of its pages, chapters, what have you. And those chapters signify information in terms of what the knowledge is supposed to represent. Now, that's the extent of my knowledge. Like, I don't know much about knowledge and classification and knowledge management in order to be able to explore this further. But it's a very interesting question. If you were to get books to talk to each other, how would you do it? Or any document at that. So how would I, for an uneducated person like me who knows nothing about these questions, how would I approach it? I would start with the classification. Then I would, how do you bind or consolidate information that is represented in area, like a page or a couple of pages, and what that's supposed to represent. Also important is the question of why would you do this? Well, why wouldn't you do something like this is the question, because there's so many different realities that could come out of this. This could greatly expedite scientific research. This could expedite discovery of all sorts of things. It would kind of be like a new reality of sorts, even beyond Project Sanity. which was just the hyperlinking of information in a more like supposedly better way compared to how the World Wide Web exists today. Again, this is not a novel concept. There's people written, it looks like, some research papers on this subject, but not a lot of people are reading these research papers, at least based on the preliminary Google searches that I've conducted. So let's do like a use case, going back to the question I posed. Like, you have that classifier, and I am interested in going to Venus. And I'd like to know all the knowledge that exists or information that exists in terms of how to actually chart a course to Venus that's going to allow a biological body like myself, who for their sense of, for the purpose of well-being and safety, requires that the temperature around them is maintained to a certain degree. So my logical domain of research would be something in the realms of material science. So I have this construct, this new talk to documents to and books to each other construct. And the command I issue to this construct is, find me the information that's going to allow me to construct some device that will allow me to maintain an internal temperature of 25 degrees Celsius when the external temperature is, say, I forget this, I should know this, say 1800 or something like that Fahrenheit outside of this construct. Now, that's a relatively complex query. I don't think Google's able to handle that as of yet, but I think something like Viv AI, that I don't know if it's released, has been in the making for a while. Something like Viv would be able to parse through all of that information, in theory, at least, I think. Because the way they've struck, something on my face, all the wool. The way they structure their, however their system works, their system is able to parse through more complex queries than what Google can handle right now. So this query that's just positive, like, so you have an internal dynamic and an external dynamic, and the information that's being passed through the machine in natural language, or you can type it up, is to be able to make sense out of what's being hypothesized, and almost kind of like go out and go through a body of knowledge, whether it's indexed or not, and parse through this information. So how would the machine do this? How would the machine tackle this problem? Well, first, the machine has to break down each one of the constituent pieces of the query that's been passed over to it. So I don't know how this is done, but with the words how, it would maybe posit that it's being asked to perform some kind of a prediction or find out a method of source. Query related to space or dynamics would posit that we're talking about a spatial, actual thing versus some abstract idea or some method to cook something, and then the query, and I'm trying to boil it down and like do the fundamentals. And then the query is being posited that you are comparing the internal dynamic of an environment with respect to its external dynamics. So the machine is being asked to make a prediction in terms of what set of materials can power this reality. So you got an external dynamic, and then you have an internal dynamic. So we haven't gotten into the issue of radiation and all of those things. So that would be something you build up on. We just gave it a simple query. The query that was posited is that we've got to maintain a temperature of this degrees Fahrenheit, or actually Celsius. So we said, it's got to do the conversion too, by the way, because we said internal is 27 degrees Celsius and external, I think I said 1800 Fahrenheit. Oh, this shakes if I bang my fist on it. So yeah, the machine's going to be able to make sense out of all this stuff. So it's going to somehow I don't know how this VBI and things like this really work. And then it's going to go and parse through the known data set that it kind of knows about. And then what does it do after that? Does it run simulations as a result of the query that's being passed? Ideally, that would be a very interesting form of a computer. I wouldn't call it a multivac in a Asimov sense. I mean, I haven't read all of the. Oh, this is from the last question. Not, I don't know if multivac was in Foundation, but that would be a very interesting computer that can take natural language or any query that's being passed over to it, and actually conduct simulations in order to be able to then go and it's a mid stage to passing information back to the user. So query sent, some extraction is done, then simulations are run, and information is collected as a result of running those simulations. And then finally, the query is passed back to the user after all of these steps have happened. It's more than just indexing a known body of knowledge, which is very important as it is. As humans are creating all this information. It's amazing. Well, it's good. I mean, all this information is being created. We haven't indexed all the internet. Obviously, it's a portion that, and a lot of it is dark. But this is beyond. I mean, I'm talking about more. I'm talking about something beyond the indexing. So this is the ability to conduct simulations. We're back, sidetracking from the conversation, but coming back to the question of how documents will talk to each other. How cold is it today? What's the temperature in Toronto right now?
It's minus 21 degrees in Toronto right now.
Yeah.
There is currently an extreme cold warning in effect.
Yeah, no shit. It's really cold. Feels like minus 35. How would the documents talk to each other? You have the classifier, and then I use this example of simulation. So it's using a simulation. The query is using a simulation. So would the documents also use a simulation? Is it do you need a simulation engine for documents to be able to talk to themselves? So you have some kind of a cog model or a cognition model, and then you enable a layer of simulation model, and then you feed this document into this construct, which is a cog model and a simulation model. So what the cog model and the simulation model do is they extract the information from the document and then they simulate what the information suggests. You almost kind of make a story or a movie out of it. But is that computationally efficient is the question. Do we even care about that question? These are all good questions, and I think they are good questions, I'm not sure. Or is there a completely different way of doing it? So you have the the cog model and a simulation model, and then you feed the information. Again, I'm repeating this, obviously. I'm just trying to think if there's any other way, potentially, but cog model, simulation engine, feed the information is extracted, a simulation is created in order to be able to do what? Why would you do that? Why would you create a simulation? Okay, so let's think about it this way. What do humans do when they read a book? So two humans, whether in the book club or not, have read a book. Say I've read the book Mindset by Carol Dweck, because it's been I recommend this book a fair bit. And somebody else has also read this book Mindset by Carol Dweck. Now we stumble across each other and we say, "Oh, you read this book. What did you learn from it? What do you think about this concept?" So we're talking about, I guess, what was extracted based on the information that presented. So there's a whole set of questions about information grounded in truth versus not, and but I'm just not going to focus on the bare bones right now. I'm not focusing on well, I wouldn't call it function, like applications in the realm of science or scientific research or discovery of some sort. Let's keep it very basic, bare bones. When the two humans talk to each other, they talk about what was learned, what are the ideas that were shared, what was your interpretation, and stuff that's actually I'm going to refrain from commenting on that most suppositions are open to interpretation. But you can kind of wrap your mind around what somebody else is sharing with respect to what you believe the author would have suggested or is suggesting. Now, there's a certain degree of variance when it comes to that information being shared. What is also happening when two individuals are talking to each other is that their mind creates a link between them of sorts. And it's not just the link that is for a normal, regular conversation. The information passing through the senses, mostly sight and auditory in this sense. And there's a series of algorithms, genetic algorithms or biological algorithms that are powering this translation for the signals to be processed by the neocortex. So I'm not talking about that kind of link, but like there's a like when you're talking to somebody, and specifically when you're empathizing, and kind of it's kind of like an invisible channel of sort that opens up between two people, and you're trying to extract the information based on the mental models they're presenting. And what you do is you don't do this consciously. I don't think so for a lot of people, but I don't do that. I don't think so. But the information is passing through your mental models for based on a lot of different things like biases and whatnot. That's what then you decide if that is something that you will adopt or hold as valid or truthful in your mind, and then absorb that information. And then you will see, based on some mechanism, whether you want to do something with that information, whether then or at some other point. So it's like, I mean, you'll leave it at that. So that's what's happening when two individuals are talking to each other, with respect to them discussing a body of knowledge, a book, a document, or something. So I guess for books to talk to each other, for documents to be talking to each other, you would need some kind of a cog model, and you would need a very rudimentary simulation model. It doesn't have to be expansive. So then you have to kind of create a world of sorts, like a Minecraft kind of a reality. And then you take a cog model, and then you take, I don't know, maybe Amazon's literature, or all the books that Amazon has collected, or you could try with a smaller subset. You can download books on a certain bunch of topics, and then what you do is you basically give some kind of instruction to this construct. It would come from the cog model, and you'd say, go read Carol Dweck's research and compare it to what David Allen from Getting Things Done or Cal Newport from Deep Work is suggesting, and see what recommendations. But there's still it's a very targeted, focused, linear kind of a query. It's still very linear, but I think it's an interesting question. It would, I like discovery. Discovery was supposed to be the next thing after search in a Randy Commissar sense. Randy made these comments a while back. And discovery may have been powered on top of a couple of apps. But the question remains, how do you get information or knowledge specifically, to talk to each other? How do you get this to talk to each other? How do you get knowledge to talk to each other? Do you do it with a cog model and a simulation engine? Or do you do it with something else? I think it's a very good question. I'll leave the question. I'll end the video on that important question. Thanks.